We present DPC-Net, Deep Pose Correction for Visual Localization, a method to fuse the representational power of deep networks with efficient classical visual localization. Recently, significant research effort has been dedicated to replacing classical visual localization approaches, like visual odometry, with monolithic deep networks. Although this is an appealing way to harness the power of deep methods, these approaches force the network to learn appearance changes and projective geometry from scratch. We contend that this is not necessary. Instead, we propose to learn small pose corrections to an existing visual localizer for a particular environment, and then fuse these two outputs for improved localization. Our deep corrector, called DPC-Net, learns pose residuals that can account for sensor miscalibrations, estimator biases, and systematic environmental effects that degrade localization. DPC-Net is a purely convolutional network that avoids max pooling to preserve spatial information. As input, we take two sets of stereo pairs and output an unconstrained coordinate vector in the Lie algebra vector space. Our loss allows us to retain targets in their constrained matrix Lie group form. Namely, to regress small pose corrections, we define a loss based on a Mahalanobis-like geodesic distance using matrix logarithms. Our loss naturally balances rotational and translational components through a metric tensor computed from training data that obviates the need for any scalar tuning parameters. We further derive an analytic gradient based on middle perturbations of the SE3 manifold for efficient backpropagation. We evaluate DPC-Net on the KITTI odometry benchmark. We choose to correct an efficient frame-to-frame stereo-visual odometry pipeline based on LibViso2. Here, you can see the resulting top-down plots for three selected test sequences of our uncorrected and corrected localizations compared to a modern, dense-direct, keyframe-based VO algorithm. DPC-Net is able to reduce the pose error of our efficient estimator by as much as 75%, and render it as accurate as the modern dense keyframe-based approach. Finally, we show how DPC-Net can compensate for poorly calibrated lens distortion parameters. We artificially distort and crop images from each KITTI sequence and retrain DPC-Net to correct our estimator on this corrupted data. Our results show that DPC-Net is able to reduce mean translational segment errors by 50% and correct localization to nearly the quality of the undistorted case. In conclusion, we believe the deep pose correction paradigm is a promising way to incorporate deep networks into existing localization pipelines for robust long-term autonomy. Please note that you can find a PyTorch-based implementation of DPC-Net on GitHub. Thank you.